In the vast ocean of space, there is a coastline we cannot cross. That's where we see the edge of the universe. Beyond this edge, it's a realm shrouded in mystery. Even the most advanced instruments built by humans can't touch. But what is this edge? What is he hiding behind? The universe we observe. It's a bubble of time and light, a snapshot of the universe dating back 13.8 billion years. But as space itself continues to expand, the universe we see today is much larger. It's about 93 billion light-years wide. Galaxies we observe near the edge. Here they are billions of years ago, bathed in the afterglow of the Big Bang. However, these galaxies continue to evolve, drift and aging. They're not where we see them. They have traveled billions of light-years farther. Some may no longer exist, but looking for the earliest galaxies can help us determine, are we understanding the universe? On track. Although these galaxies may have drifted to the point where we can't touch, but the light they emit as they travel, possibly contained in cosmology, answers to some of the greatest mysteries. James Webb. The Space Telescope was built for this very purpose. He's only catching light from the early universe, reveal its secrets. The latest observations from the James Webb Space Telescope shocked scientists because he has exceeded the limits of his abilities, revealed so far the oldest structure ever observed, entering completely unknown territory. Welcome to the field. James Webb Space Telescope. He may have broken his own record again. If the scientists' conjectures are correct, this groundbreaking observatory may have captured a glimpse of the universe's earliest galaxies. He found more than just one, but 5 such ancient galaxies. If confirmed, it's going to turn our model of cosmology upside down. Currently, James Webb, the most distant galaxy observed by space telescopes, JOGS 114. He presents the universe about 280 million years old. But with the discovery of these new galaxies, everything will change. These 5 galaxy candidates are so distant, so much so that the furthest one looks like after the Big Bang, only 150 million years. This means that the light of these galaxies has fulfilled approximately 13.6 billion to reach Earth. However, due to the expansion of the universe, these galaxies, now estimated to be an astounding 34 billion light-years away. This discovery was made by James Webb Space Telescope, Galactic Legacy, Infrared Mid-Plane Sky Search Excellence Project, part of the Glimpse. According to researchers, these galaxies are so distant, follow-up observations are required to confirm their distance. It is estimated that these galaxies are indeed cut age and travel time, still very challenging. But we're certainly approaching the first generation of galaxies because we only have about 150 million years left to form these galaxies. Time is so tight, there aren't many ways to form galaxies. What is really strange and extraordinary is that the SCARF telescope now routinely finds the red meter at Z equals 10. Z equals 14 galaxies. For reference, the earliest confirmed red meter of galaxy, JSC 14, is Z equal to 14.2. However, the redness of these 5 new galaxy candidates is Z is 16 to Z is 18. So, can telescopes detect even older galaxies? Scientists are more concerned about the existence of these 5 candidates. James Webb Space Telescopes have the potential to discover even earlier galaxies, but it will depend on their number, density, and brightness. And it has to do with the way information about early galaxies unfolded. We are entering completely uncharted territory. Not sure what we'll find. Many of these sources are expected to be very feeble, even with the SCARF telescope for spectral confirmation. It will also be extremely challenging or not feasible. Despite this, the GLIMPSE project is just getting started, has pushed the telescope to its limits. Who knows where he will be in the future? What else will it hold? Earlier this year, the James Webb Space Telescope discovered one, the galaxy called GLASSZ13. He was formed only 290 million years after the Big Bang. Webb also found another galaxy candidate, Galaxies 1 by 1. He was formed 500 million years after the Big Bang. First 1 billion after the Big Bang period universe. It resembles a busy construction site. Galaxies and galaxy clusters are under the influence of gravity, formation, and evolution. For the modern universe we see today, laid the foundation. Now James Webb Space Telescope, 3 galaxies have been discovered. Red Monster Galaxy. This appends our understanding of the first galaxies. How to form an understanding. An international team led by the University of Geneva. It's been identified 3 super large mass types. They are almost as big as our Milky Way galaxy. Within the first 1 billion years after the Big Bang. Space Telescope's FRESCO project utilizes near an GRIM spectrometer. Precisely determine the distance to the galaxy and the mass of the stars. The findings, published in the journal Nature, suggest that the efficiency of star formation in the early universe, much higher than our model predicted. The favored theoretical model suggests that galaxies are forming in this dark matter bonanza. These transport attracting gases, creating structures with attractive forces, usually only 20% or less gas, into stars in the galaxy. However, these latest findings challenge that view. Researchers believe that massive galaxies in the early universe, perhaps more so than later galaxies, to form stars more efficiently. Its growth rate is much faster than previously thought. The remarkable capabilities of the Webb telescope, allowing astronomers to investigate early the far reaches of galaxies in the universe, and got a new perspective on massive dust-obscured galaxies. FRESCO's analysis revealed that most of these galaxies, consistent with current theoretical models, but the data also revealed, shows 3 particularly massive galaxies. Its stellar mass, compatible with today's Milky Way. The stars in these galaxies, they are almost as efficient as their smaller counterparts, and twice as many advanced galaxies, due to their high dust content in James Webb. In the image of the Bohr Space Telescope, shown in a striking red. Therefore, it is called the Red Monster. What we found, its heavy, shape our understanding of the formation of galaxies in the early universe. Dr. Sear, the lead author of the new study, said, "The immense characteristics of these red monsters are depicted in James Webb. Space telescopes have been difficult to determine before. Because they decay due to dust, it's not visible to the optical field." Dr. David Elvis says, although these observations, consistent with current cosmological models, but they theorized about galaxy formation, presents new challenges, especially considering that there was so much in the early universe, and galaxies that are too large to explain these. Massive scale with efficient star formation, early galaxy, the existing model. It may be necessary to incorporate extraordinary mechanisms, allows for such fast delivery. What's so surprising about these massive galaxies? Because they exist so manufactured, we don't think they have time to form. Assistant Professor Eric Nelson, in the Department of Astrophysics and Planetary Sciences. It's like coming home from work and checking on your kitten, and you find a cougar on your couch. Although Nelson previously helped identify some red monsters, but new research, and I took a closer look at the candidates. Make sure they are. It's as old and massive as it looks. For some reason, these galaxies manage to, over billions of years, transforming almost all the gas into stars. That's on cosmological timescales. Just for a moment. Another scientist from the team said, future research will use James Webb Space Telescope and the Atacama Large Millimeter Array ALMA Come and learn more about these ancient supermassive red galaxy, and may find more of these early. The example of a cosmic giant. Speaking of size 1 telescopes, here's another one about the universe. The surprising discovery of origin. An impossible galaxy Rebels 25 by the Atacama Large Millimeter Array ALMA telescope discovery. This galaxy has upended our understanding of galaxy formation. Astronomers made a surprising discovery. This distant galaxy, formed only 710 million years after the Big Bang, looks amazing like our own Milky Way galaxy. It's a giant disk galaxy. Signs of a spiral arm. There's even a center bar. This discovery has astronomers scratching their heads. How is it possible that the universe was still in its infancy? There is such an ordered galaxy. Further observations of this galaxy reveals that he is more than just an ordinary early period galaxy. He is the furthest intense ever discovered rotating disk galaxy. To confirm these findings, astronomers use ALMA, and I took a closer look at this galaxy. High-resolution data. Not only does it confirm that the Rebels 25 has a spinning disk, it also suggests other advanced features, like a central extension strip and the start of a possible spiral arm. These characteristics, more in line with our silver, mature galaxies like Galaxies, rather than one born near the Big Bang, raw galaxy. So, what does this mean for our cosmology? The discovery of Rebels 25 is revolutionizing our understanding of the early universe. It shows galaxies may have more rows than we previously thought. They evolve faster. Left to scientists, the birth of galaxies in the universe, and the growth of exciting new enigmas. Further observations will help unravel the mysteries of the early universe. What do you think? Welcome to the channel to leave a message to discuss.